Hi, welcome back to McClatchy Maths. My name is Natalie McClatchy and today we are continuing with our video series on algebra by looking at solving equations with unknowns or letters on both sides of the equal sign, and this is our 14th video in the series. We've got three examples starting from relatively simple up to fairly complex. Let's go. First example, 4x plus 7 equals 2x plus 15. Now I have a process that I like to follow when I'm solving equations. I'm going to show you my process. Your teacher may have a slightly different process. It doesn't mean that either of us is right or either of us is wrong. It just means that we get to the same place in different ways. So don't panic if I show you something slightly different. Okay, so what I like to start with is bringing like terms together and grouping them on the opposite sides of the equal sign. So you can see on the left-hand side of this equation, it's always a good idea to inspect our equation first. I've got 4x plus 7 here and 2x plus 15 here. Now these are not like terms, so I can't just squish them together and make 11x. And same on this side, I can't squish them together and make 17x. They're not like terms. The like terms are the 4x with the 2x and the 7 with the 15, but they're separated by that equal sign. So what I need to do is group the letters on one side, the numbers on the other. So what I'm going to do is I always follow a little rule, take the smallest coefficient to the side with the big one. The reason why I do that first is because otherwise you could end up at the very end with a negative letter. And that means you've then got to divide everything by -1, which is messy. So it's a lot easier to start in a place that's planning forward so that you end up in a place that's a good place at the end of the equation. So always take the small numbers to the big numbers on with the letters. Okay, so letters first. So we're going to take 2x from both sides, and then we're going to take that away over here as well. So taking away 2x from this side means I'm going to end up with 0 on this side, plus 15. And then on this side, 4x take away 2x gives me just 2x plus 7. Okay, so now notice that I'm doing things really neatly. I know a lot of students don't like to be neat, but algebra is easy to make mistakes. So if you line things up neatly on top of one another, it's a lot easier to keep your working tidy, communicated well to the marker of your work, but also easier to see if you've made an error. So here, you'll notice the taking away, I've put it straight underneath. Some students pop it off to one side. I do see students that pop it off to one side tend to make more mistakes because they'll take things away from the wrong thing or they'll forget to do it from both sides. That's why I like to work sort of like a sum. Okay, so underneath the 2x, I'm taking 2x away and the answer falls underneath. Nothing had happened to positive 7. It stays in the same position. Nothing happened to the equal sign. It stays there. 15 though moves over because we've taken away, that's now 0 in that position. We're still going to continue to collect like terms now. We've still got to collect the 7 and the 15 together. So to get this side, what I'm trying to do is get 2x all by itself. So I'm going to subtract both sides by 7 now, and I'm going to be left on the left hand side with just 2x, and on the right hand side 15 take away 7 makes 8. I'm still not finished. I still got to get x all by itself, making it the subject. So what I'm going to do at the moment is have another little inspect. This is a multiplication sign here. 2 times x equals 8. So what I'm going to do is undo multiply with divide. So divided by 2, divided by 2. 2 divided by 2 is just 1, which is just 1x, and we only write x by itself. We don't need to write the 1 in the front. So we've just solved it. X equals 4. Now it's a good idea to inspect your equation at the very beginning, but also to check your work at the very end. So what I'm going to do now is, if I know x equals 4, everywhere in this equation, I'm going to substitute 4 back where I see an x and just check my work. So 4 times 4 makes 16, plus 7 is 23. Yes. And 2 times 4 makes 8, plus 15 also makes 23. So 23 equals 23. I've solved the equation with x being equal to 4. Let's look at our second worked example. Now, if you don't know anything about brackets, it's a good idea to watch 2 of our previous videos, in fact. One of them, very early on in the series, talks about expanding single brackets, and the other video was the one we just did before, and it talks about how to expand brackets in equations. Now, in that last video, I showed you 2 different methods. There's the long way and the short way. The long way is to expand the brackets first. The short way is to divide this side by 3 and that side by 3, and that gets rid of the brackets straight up. Now, normally that would be my preferred process. However, you'll notice here that we've got x plus 7 on this side. This is why it's a good idea to inspect first. If I divide this side by 3, I've got to divide that side by 3. Then I'm going to end up with 7 divided by 3 and x divided by 3, even worse. So let's not do any expanding brackets just yet, or any dividing by 3, sorry. We're going to expand the brackets first. Let's make this side a bit simpler, multiplying everything by 3, because these brackets mean times. So 3 times x, 3 times minus 2, gives me 3x take away 6. Now I've got something I can solve. It's a lot easier to solve. So what I'm going to do now is what I did in the last example, small x's to the side where the big x's are. So we're going to take those x's away from both sides. We're collecting the like terms here. So 3x take away 6 gives me 2x on the left-hand side, and x take away x on the right-hand side gives me 0 there. So now I'm going to have 2x take away 6, nice straight columns there, all the equal signs on top of each other, and just 7. Okay, now I'm going to bring the negative 6 to the other side by undoing take away with a plus. We're going to add 6 to both sides. That will give me 6 take away 6 on the right-hand side, the left-hand side, which makes 0, and 7 plus 6 makes 13. So now I've got 2x equals 13. Now you might be thinking, oh, 2 doesn't divide neatly into 13. Have I made a mistake? No, you haven't. You can have answers in algebra that are decimal answers or fractional answers. That's quite okay. Personally, as a teacher, I prefer to keep them in algebra form. Once I've divided by 2 for both sides, I like to keep it as 13 over 2. It makes it much easier to then substitute that back in for checking, and also to substitute back in if I have to substitute and find a solution to something else. You could use your calculator and find it was 6.5. Typically, if you find some really awful answer, like if it was 103 over 5 or something weird like that, that gave you a decimal answer with infinite decimal places, that could be a little bit of a clue that you've made a mistake. Always a good idea to then substitute that back into the beginning problem and check your work. However, in this case, it is correct. Okay, worked example 3. Now you'll notice this time we've got a fraction on the left-hand side. And it's a little bit awkward. Now, the tempting thing that I would see a lot of students do here is go, ooh, I've got an x on the top and an x on the bottom. Let's cancel those out. I'm going to cross that out with that, and then I'm going to cross that out with that, and then do 8 divided by 3 on my calculator, and then just work it out from there. Well, that would be a disaster, because not only have you cancelled out the x's, you've got nothing left to solve. So that's where people would get unstuck there. In this case, what I'm going to say is, we'll leave those expanding of brackets for a little while first. What we're going to do is we're going to undo the fraction first. The fraction is making it complicated. Let's make it simple. So we can undo that by dealing with the denominator. We've got a division sign here. We're going to undo the divide with times. We're going to multiply both sides by times, and then we'll collect our like terms after we expand the brackets. So what I'm going to do is multiply both sides by 3x. What's going to happen here now is I've got 3x divided by 3x makes 1, so it's disappeared, the 3x's. And on the right-hand side, I've got 10 times 3x, which will make 30x. Now I can expand those brackets, so 4 times 8x will give me 32x, and 4 times negative 2 will give me minus 8. So 32x take away 8 equals 30x. Now it's looking a lot simpler. Let's bring that 30x to the 32x, because what we need to do is collect those like terms now. So we're going to take 30x from both sides of the equation, and we'll end up with 2x take away 8 equals 0. Now this is another panic point for students as well, because you don't see many equations where you've got 0 on one side of the equation, and it causes students to sort of think, oh, I've done something wrong here, what have I done? You haven't done anything wrong. We've just taken everything from the right-hand side of the equation to the left-hand side of the equation. So there's nothing on the right-hand side now, but we're going to put something back there now. Let's put the positive 8 back so that we're still collecting those like terms and getting 2x all by itself. And our final step for this example is to divide both sides by 2, and we find x is equal to 4. A good idea here to also take x equals 4, substitute it back in here at the very beginning, and you'll find that you've done it correctly. Well, did you find this video helpful today? If so, here's some ways you can engage further with us here at the channel. You could tell us in the comments, you could share the video with a friend or a teacher, or even follow us on Facebook and Instagram. But if you have any questions, the best place to ask is at mcclutchymass@yahoo.com. Drop us a line there. Well, thank you so much for watching today. Appreciate your time. Have a wonderful day.